Welcome to Shooting Star News. In this episode, we will review the most recent findings on the interstellar comet 3iATLAS. Several new observations have been published over the past weeks, and together they provide a clearer picture of the comet's activity, composition, and trajectory as it moves deeper into our solar system. On September 7th, during the lunar eclipse, astronomers Michael Yeager and Gerald Raymond obtained images that suggest 3iATLAS may be developing a green hue. This is not yet confirmed across multiple observatories, but if verified, the coloration is likely connected to the release of cyanide or similar molecules fluorescing under solar radiation. The strength of the glow appears unusual, and continued monitoring will help determine whether this is a transient feature or a sustained development. Data from the James Webb Space Telescope have revealed that the comet's coma is strongly dominated by carbon dioxide. The ratio of CO2 to water is about 8 to 1, significantly higher than what is typical for solar system comets. This unusual chemistry suggests that 3iATLAS may have formed in a region of its parent system rich in carbon dioxide ice, or that it has undergone processes that altered its volatile inventory over time. Either scenario points to a very different formation environment than what we see in our own solar system. Despite being more than 3.5 astronomical units from the Sun, or AUs, over 325 million miles, or about 523 million kilometers, the Swift telescope has detected water activity through the presence of hydroxyl emission. The estimated rate is about 40 kilograms per second. For this to occur at such a distance, a large fraction of the comet's surface must be active. This is a notable contrast to many comets in our solar system, which tend to remain relatively quiet at the range that it's at the distance. Polarimetric studies have shown that 3iATLAS scatters light in an unusual way. It exhibits extreme negative polarization at small phase angles, down to minus 2.7%. These values differ significantly from most solar system comets and asteroids. The behavior is more consistent with trans-Neptunian objects, suggesting that the dust and surface grains of 3iATLAS have distinct properties not commonly observed in closer comets. As the comet approaches the Sun, its activity is evolving. Photometric data show that at distances beyond 3 astronomical units, brightness followed by a steep curve close to the 4th power of distance. Now that slope has flattened significantly. At the same time, the comet's color has shifted from red to a more neutral tone, coinciding with the development of a longer tail. This indicates that new layers of volatile material are being exposed as the comet warms. 3iATLAS is now approaching 2 key milestones. On October 3rd, it will pass within approximately 30 million kilometers or 18 million miles of Mars. Orbiters around Mars may be able to capture valuable data during this approach. Later in the month, around October 29th to the 30th, the comet will reach its perihelion, its closest distance to the Sun, at about 1.36 AUs. These encounters will provide critical opportunities to study how the comet responds to increasing solar energy. The findings to date underscore the differences between interstellar comets and those native to our solar system. The dominance of carbon dioxide, unusual polarimetric properties, and sustained water activity all highlight how diverse the building blocks of planetary systems can be. Each interstellar object that we come across that passes through our solar system offers a unique perspective on conditions elsewhere in the galaxy. With continued observation, 3iATLAS will help refine our understanding of how planetary systems form and develop. So, this has been the latest update on 3iATLAS. We will continue to follow its progress as it approaches Mars and then the Sun later this year. Thank you for joining us on Shooting Star News, and we'll see you next time, folks.